Alright, welcome to CXC Math TV. Today we're going through the 2022 Unit 2 Paper 1. So this is the last year paper. First one, we want the locus that represents the modulus of z minus 5i equal to 3. So notice this is really z minus in bracket z 0 plus 5i equal 3. So that means the center, the x value is 0. And the y value is 5 and the radius is 3. So looking for 0, 5 as the center, the x is 0 and the y is 5. A out. X is 0, 5 here. So notice 0, 5 is only this one, option B. Now the radius should be 3, so them kinda don't draw it to perfection because if you move it over, the radius should be 3, so they didn't draw this so wonderful, but that's okay. B is the answer. Number 2, this is a repeat from the last year paper. I remember it was 4x plus 7. This was the answer. X squared minus 4x plus 7. Alright, that was the answer. Number 3, which of the following is always true? No, the argument, the modulus is going to be the same. So let's say you have 2 minus 3i and 2 plus 3i. Both of them going to have the same magnitude. The arguments won't be the same. Now z times z bar is real. Yes, 1 and 3 is real. So anything with 2 out, 1 and 3, B. Number 4 is a repeat from the last year paper that we just did, and I think we got minus sec that. This one was a repeat, and I think we got negative 1. Right, so yeah. So we just run through repeat question, don't need to rework them. This is a repeat, but I tend to not remember everything. So just to do it back again, this was 2x plus 2y dy dx equals 0. Divide through by 2 and then bring over. This is saying y dy by dx is equal to, divide by the 2, bring it over, that's negative x. So dy by dx is negative x over y. X is 3, y is negative 4, so that's negative 3 over negative 4 is positive 3 over 4. So 3 over 4 is option C. Now we need to differentiate cos inverse x over 2. So that's 1 over the negative 1 over the square root of 1 minus x over 2 square multiplied by the derivative of x over 2, which is half. So this is negative 1 over 2 times the square root of 1 minus x squared over 4. Now if you want, you can write this as one fraction because that's what they do. So remember 1, I'm going to change 1 to 4 over 4. And so I'm going to factor out quarter. So I have minus 1 over 2 times square root, factor out quarter, and I'm left back with 4 minus x squared. Then I have minus 1 over 2 times square root of quarter in bracket 4 minus x squared. Then basically I need to work out what is 2 times square root a quarter, which is 1. So in that case, notice that is just negative 1 over 4 minus x squared being square rooted. Alright, so that's all. That's option A. Number 8, product rule. I'm going to have to zoom in because this one not so clear. I can hardly see. I think it's saying e to the x squared ln x. So in this case now, to differentiate it, let's call this u, right? Call it u. X squared ln x u. So if we call it u is x squared ln x, then du is equal to differentiate it using product rule. Keep the first times the derivative of the second plus keep the second times the derivative of the first. When you differentiate x squared, you get 2x. So therefore, f prime of x is equal to e to the u, so it's e to all of that, which is x squared ln x times du, and du is x squared times 1 over x is x, plus this is x plus 2x ln x. If we factor out x, that is x e to the x squared ln x in bracket 1 plus 2 ln x. I can bring up the plus 2 and write the plus 2 here as ln x squared. So that's what we're looking for. 1 plus ln x squared. I only see it in option A. So that's it. Number 9, when you integrate, this is e to the 2x minus 1. If you're not seeing it so well, neither am I. So that's why I'm writing out the question. Alright, it's just how the paper was, So integrate, and the 4 is outside. Integrate this. This is 4e to the 2x minus 1 divided by 2. 4 over 2 is 2e to the 2x minus 1. That's a joke thing. D. Number 10. I know this is repeated, but it's so hard to remember so much, right? But we're going to work it out again. Using product rule, keep the first times the derivative of the second plus keep the second times the derivative of the first. When you differentiate 2x cubed, you get 6x squared. Minus when you differentiate 3x, you get 3. Equal to when you differentiate negative 6x, you have minus in bracket. Keep the first 6x times the derivative of the second y prime plus keep the second y times the derivative of the first. Differentiate 6x, you get 6. Now you need to make y prime the subject, but I can't bother with all of that, so I'm just going to plug in the x as negative 1 and the y as minus 3. 2 times minus 1 cubed times dy dx plus 6 times minus 1 squared times negative 3. Minus 3 is equal to negative in bracket. Let's work out this part now. 6 times negative 1 times dy dx plus right here is now 6 times y, and y is negative 3, and then we'll just put all of that in the calculator now. 2 times negative 1 cube is negative 2. That's negative 2 dy dx. Then now we're gonna work out now 6 plus, well, 6 times negative 1 being squared times negative 3, and then we subtract our 3, and what we're getting is negative 21. So minus 21 equal negative of, work out all of this now, negative 6 times minus 1 is negative 6, but negative and negative become positive 6 dy dx. Then 6 times minus 3 is negative 18, and then negative of negative 18 is positive 18. So we're going to transpose for dy dx and bring this question back up to the top. Bring the dy dx on one side, so bring dy dx over here. 2 plus 6 is 8, dy dx equal, bring the 18 to the other side, that's minus 39, divide by 8, so dy dx is negative 39 over 8. That's B. Oh, that's a lot of work. This one now, we need to express it in the form a plus bi. So, but this is still not even in that form, so I don't know what they're talking about. So in that case now, remember the Moivre's theorem, so 3, is that a square or is that a cube? It's a cube. So in that case, it's 3 cube in bracket. The Moivre's theorem, and multiply 3 times 40, so it's cos 120 plus I sine 120. 3 cube is 27 in bracket. Cos 120. Put in a calculator. Cosine 120 degrees. Make sure it's in degrees. That's negative half. Plus sine, I sine 120. Sine 120 same as sine 60, which is root 3 over 2i. That's the answer. So we're looking for minus half here, A. This one now, oh boy, differential equation. Differential equation in module 1, that's a mistake. It shouldn't be in module 1. We know this should be in module 3, so that's a genuine mistake from Kate, but dy dx is this y square or y cube? Uh, it's y square. It's y square minus 1, based on what the denominator have. So in this case now, it says the solution of the differential equation. Oh, it's just partial fraction, no problem. So in this case now, we need to bring it over and write it as dy divide through is 1 over y square minus 1 equal 1 dx. Then we're going to integrate both sides. But to integrate 1 over y square minus 1, we're going to have to break it up in partial fraction. So 1 over y square minus 1 is a over y plus 1 plus b over y minus 1. Now this is so stupid, Cape. You don't give us any space to work out the question. How are students going to work out the question, Cape? Do better. So in this case now, we don't have no space. So we go to the blank. 1 over y square minus 1 equal to 1 over y plus 1. Well, a over y plus 1 plus b over y minus 1. LCM. Let me not use LCM. I don't have time for that. Let me plug in let y equal 1. So we get 1 equal, this is a times, remember, y minus 1 plus b times y plus 1. And plug y as 1. This is 1 equal a times 0 plus b times 2. So that means 2b is 1. So b equal half. Then if I plug in y as negative 1, then 1 equal negative 1 minus 1, so a times minus 2 plus minus 1 plus 1 is 0, so b times 0. So minus 2a equal 1, a equal negative half. And so in that case, 1 over y squared minus 1 is equal to a, which is minus 1 over 2 in bracket y plus 1, plus b, which is 1 over 2 in bracket y minus 1. So we start with the minus 1. This is what we need to look for. We're integrating. They didn't give us any space to do any of that. So looking for positive 1 over, here it is, d. Positive 1 dy over 2y minus 1 minus 1 over 2 in bracket y plus 1. They put the negative after. That's good. This is a repeat question. I think it was A. It's a repeat. Alright. Now, this question now, number, what we call this, 14. Number 14. The principal value of the argument of the complex number. So in that case now, remember, in this case now, remember, this is minus 2 and this is 2. So in this right here, so this is the argument. So the argument is tan inverse b over a. So tan inverse 2 over minus 2, which is tan inverse minus 1, which is negative pi over 4. But it's pi plus. So pi plus negative pi over 4 is 3 pi over 4. That's the argument, 3 pi over 4, because it's in the second quadrant. Differential equations again. This is a differential equation. Given that s is 0 and t is 0, for s in terms of t may be found by solving, so we cross multiply and divide through. So where does x come from in this question? Let me read it again, because I see in x and y here, but this question have s and t. So in a chemical reaction, the amount of substance S present at time t is modeled by this differential equation. So where A and B are positive and A is greater than 0, given that S is T, which of the following? Alright, so I notice they turn the S to X, they turn the X to S, and they turn the T to Y. So in this case, picture it as ds turn X and this turn Y. Now why I do this, it make it easier for us to see what is happening. So now of course we need to group up the X. So divide, that is now, we can say 1 over a minus x times b minus x dx equal k dy. And then we integrate both sides. So looking for 1 over a minus x, b minus x, k dy. Alright, that would be fine. That would be fine. Alright. So and k is a constant. So this option and this option, I want to see what are these limits, because these are the a and b are fine. A and b are fine. I can hardly see. Because I can hardly see, I can't make any. These two are basically the same. If we divide through by k, it would be 1 over k. So in this case, it would only be option B then, following what we have. I can hardly see option A, so this paper was sent a little bit blurry. Number 16, the 20th term. I know this repeat, but can't remember. So to find the 20th term, we put n as 19. So u n plus 1 is 1 minus 1 over 1 plus un. I will need the 20th term. So u n is 20. I put 19 here. So u 19. Well, actually can't start there yet. I might have to find u2 and develop a pattern. So u2 would be 1 minus 1 over 1 plus 1. And 1 plus 1 is 2. So that is half. Now u3 is going to be 1 minus 1 over 1 plus u2, which is half. Then I need to catch the pattern here. So now u3 is 1 minus fraction button 1 over 1 plus half. Don't worry guys, I'm catching a pattern. This is 1 over 3. I catch it already. So u4 is 1 over 4. All the way down to u20 is 1 over 20. Okay, no problem. That's easy. Fair enough. Number 17, this is a repeat from the last year paper, 8 over 3. This part, given that un represents the nth term in a sequence, which of the following diverges? It diverges if you can put in a big value, it's going out to infinity. or you divide through by whatever, but clearly this converge. All right, this one converge. This one out because this one converge. So really checking the others. They always tell you to divide through by the highest power of n. That's one way to do it. Or you can try with like big numbers. You can try, look what I'm showing you, right, with part B. Try with a big number. It's a multiple choice. We're trying to save time. 1 over big number like 50 or 5 million raised to the 5 million. 1, 2, 3, 4, 5, 6 zeros. Now I make sure in the power of 6 zeros. 1, 2, 3, 4, 5, 6, 7, 0, 6 zeros. So you notice it converged to E. This one converged to E. Now if you notice you have minus 1 raised to the first power, that's minus 1. And if you make n extremely large, 1. But if it was this, minus 1. So it's alternating. This one don't diverge or converge to this out. Diverge meaning it's going to negative infinity or positive infinity. So check with C. 4 times big number minus 3. This is how many zeros did I use? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use 2 raised to the 8 zeros again. 1, 2, 3, 4, 5, 6, 7, 8. Bam, math error. Once you get in math error, that's the one that diverge. It's going to infinity. And just to show you with the other one as well, which you don't need to do, like fraction, ln, let's go with 1, 2, 3, 4, 5, 6, 7, 8 over e raised to the 1, 1, 2, 3, 4, 5, 6, 7, 8. You notice, guess that one not working. Cut off couple zeros, cut off 2, and cut off 2. Well, either of these. So because now I'm gonna just work it out then. Evaluate the limit as n approach. I didn't want to do this, but I'm gonna have to. And I divide through by the highest power of n. So I divide through by, I don't want to divide through by 2 to the n. This method might be a little bit harder. So I'm gonna work out this is your un, so you need to have un plus 1 divided by un. That is un plus 1 is 4 in bracket n plus 1 minus 3 over 2 to the n plus 1, and this is divided by un, and dividing is same as multiplying by 2 to the n over 4 n minus 3. Then now the 2 to the n cancel out. 2 to the n leave just 2, right? Leave 2 to the 1 power. So this is now 4n plus 4 minus 3. 4 minus 3 is, what is 4 minus 3? 4 minus 3 is 1, divided by 2 times 4n minus 3, which is 4n plus 1 over 8n minus 3, divide through by n. This is 4 plus 1 over n over 8 minus 3 over n. Evaluate the limit, and we get in half, which is less than 1. When it's less than 1, we're saying that it does converge. We're saying that this one does converge. So this one actually does converge, so the one that diverges is actually D. Alright, and you could even check it as well. ln n plus 1 over e to the n plus 1 multiplied by e to the n over ln n, and then show that e to the n cancel out e to the n, so you have e to the 1, then you have log n plus 1 over log n, which by laws of logarithm, log a over b is log a minus log b. This can help with n, and it's being multiplied by e, so log n plus 1 divided by log n times e. And to evaluate the limit of this now, it shows that this one, if n is large, so like log 500 over log 499, and then it would be multiplied by n, which is 499 here. That's very small. As it gets larger, let's put a 9 there, a 9 here, and a 0 here. Gets smaller, a 9 here, a 9 here, and a 0 here. It gets even smaller. What this is saying, this is actually saying this one converge. So this is saying, sorry guys, I don't know. As you can see, middle of the night, adjusted a paper, making some mistake. This one actually does converge. This one actually does converge. This converge. This converges a C. This converge. This one converge. I can't say this one diverges. Can you say minus 1 to the n diverges? Because it's alternating between -1 and 1, so it's not diverging. These two clearly converge. As n becomes very large, this is converging. So I'll put an asterisk here, right? I'll put an asterisk there. I'll come back to that last. This one right here, 1 plus x to the minus half, and they want the third term. The third term, remember the formula for this is 1 plus nx plus n minus 1 x squared over 2 factorial. This is the third term. So in this case, n is minus half. So it's minus half times n minus 1 is minus half minus 1 is minus 3 over 2. This is now x being squared divided by 2 factorial. They work out that part. This is now minus half times minus 3 over 2. And we divide that by 2 factorial. It's 3 over 8 x squared. Alright. Number 20, the sum of the first n terms, the sum of the first n terms of a series is this. They tell you Sn is 1 minus 1 over 4 to the n. So first thing that means S1 give you the first term, 1 minus a quarter is 3/4. Then S2 tell us it is 1 minus a quarter square, which is 15 over 16. So term 2 is going to be sum of the first two terms minus sum of the first term. So 15 over 16 minus 3/4. That's 15 over 16 minus 3/4 is 12 over 16, which is, that's 3 over 16. This one now, it says the coefficient of x to the 4 using Taylor series. So Taylor series, remember, is f of 0 plus f prime of 0 times x plus f triple prime of 0 times x squared over 2 plus f triple prime of 0 x cubed over 3 factorial, then plus f quadruple prime of 0 x to the 4 over 4 factorial. So this is the one we're focusing on. So we need to differentiate cos 4 times. So f prime, when you differentiate cos, you get minus sine Then when we differentiate sine, we get minus cos. Then we differentiate minus cos to get sine. And then we differentiate sine to get cos. So we end up get back what we started with, but now we're going to put in cos 0, and cos 0 is 1. So this is now 1x to the 4 over 24. So the coefficient is 1 over 24. I remember this, and I think it's 135, but how I usually love to do it is, this is 180 divided by 360 divided by 320 divided by 3 is 20 over 3. I always split them up as the plus side first, so 180 plus 20, continue, then this have minus, this next part is a 60 plus 20 over 3, continuing. So for this part now, I notice A is 180 over 1 minus R. 20 over 180 is 1 over 9, minus this part is 60 over 1 minus, I think the same common ratio, 1 over 9. Then I plug it in the calculator. 180 over 1 minus 1 over 9 minus fraction button 60 over 1 minus 1 over 9. 135. I remember it was 135. Alright. 23. They want the fourth term. Coefficient of the fourth term. Now, I don't like when they give question like this because they didn't specify whether it's in ascending or descending order. So I'll assume it's in ascending. So remember, it's a to the n plus, this is now n choose 1, a to the n minus 1, b to the 1 plus n choose 2, a to the n minus 2b squared, that's the third term, plus n choose 3, a to the n minus 3b cubed. This is the fourth term. In that case, it is 7 choose 3. This is now 3x to the n minus 3, 7 minus 3 is 4, times 2y cubed. So we'll just put in 7 choose 3 times 3 raised to the fourth power. And then we multiply that by 2 cubed. That's 22680. That's it. C. This one now, I remember this one repeating. I think we had gotten the 3/4. This one repeat. Just to write down the repeat first. Number 28 repeat. This was 1 over 1 minus x. We just did this a while ago. Repeat. The 10th term of an arithmetic series, and they said the 10th term, which is T10, is equal to 18. The common difference is 3. So remember, 10th term is a plus 9b, and the common difference is 3. So this is 3, so a plus 9 times 3. I'm very tired, so, but just pushing through. Bring over the 9 times 3 is 27. 18 minus 27 is minus 9. That's your first term. So now the sum of the first 20 terms is 20. The formula is, remember, Sn is n over 2 in bracket 2a plus n minus 1 times b. So this is 20 over 2 is 10 in bracket 2a, 2 times negative 9, plus n minus 1, which is 19 times the common difference 3. And so you put that in a calculator. Now guys, I am very tired and you are very tired, and notice pushing through. So when you're tired, what do? Push through. 19 times 3, 390. That's C. This one now they want us to expand using binomial. It's first term cube. So 2a all cube. Then I have plus 3 times 2a squared times minus b plus 3 times 2a times minus b squared plus b cubed, that is 8a squared, then 2 squared is 4, 4 3 is 12, so minus 12a squared b, then we have plus 6ab squared plus b cubed. That's what I'm looking for. 8a cubed minus 12a squared b plus 6ab squared, that looks like c, then plus minus b cubed. Yeah, this should be plus minus b cubed, so minus b cubed c. Alright, so where's this expansion valid? If we factor out 50, that's the square root of 50 in bracket 2 minus x. So this is 1 over square root 50 times, this is now, the square root is really 2 minus x raised to the, this is 2 minus x raised to the square root is half power. When you bring it up in the numerator, it's minus half. Good. And remember, this is only valid when it's in the form 1 plus x to the n. So actually, I needed to factor out 100. So I needed to factor out 100. So I get it in the form 1 minus half x. So this is 1 over square root 100 is 1 over 10 times 1 minus half x to the minus half. Where remember this number here, so half x is between 1 and minus 1. So multiply through by 2, x should be valid between 2 and negative 2. That is option B. Alright, we did those. 29, I know this is a repeat, but I can't remember. So we're going to work it again. So number 29, xn plus 1, remember, is xn minus f of xn over f prime of xn. So in that case, it's going to be xn, or we can just use x minus f of xn e to the 2x plus 4x minus 5 over the derivative 2e to the 2x plus 4. Multiply it up, that is now 2x e to the 2x plus 4x minus all of this now. That become minus e to the 2x minus 4x plus 5. This is just a numerator I'm simplifying. From the numerator, notice what they have in common. Can factor out the e to the 2x. We're left back with 2x here. And this is 2x minus 1. And the 4x minus 4x cancel. Then I have plus 5. So this is the numerator part. The numerator over back the denominator. Alright, so this is our numerator. So looking for this one, e to the 2x, bracket 2x minus 1, plus 1 out, plus 1 out, e to the 2x, 2x minus 1. What's the difference between, oh, plus 5, my plus 5d. Number 30, I know this repeat, but can't remember. The coefficient of x to the 11 in this. So x to the 11 is all the way close down to the last one. You know the last one is x to the 12, but just before that, it would be n choose 1, a to the, well, n choose 11, a to the n minus 11, then b to the 1. But that's actually not what we want. We want n choose all the way down. We need this one to be n choose 11, a to the 1, b to the 11. This will give us what we want. So in this case, n is 12, so it's 12 choose 11. This is a times x. This is to the first power x to the 11 pound. Remember that you multiply it by 2 because there's a 2 here. So now put this in the calculator. 2 times 12, choose 11, close the bracket, times A. And I can't really say times A really. So just leave it as it is there. That's 24. This is 24 ax to the 11. So the coefficient is 24a d. Finally, module 3. We can run through module 3 usually. Repeat 32. I love to see repeat questions. It's 3 factorial times 2 factorial. Now, say mutually exclusive. So if it's exclusive, now, them tell you what going for Q. They tell us what's happening for R. And so we need to find, this is 0.3. This is 0.6. And this needs to be 0.1. So all of them add to 1. Alright, they're mutually exclusive. That part would be S. Alright. What's the product that they're prime? Finally, the correct answer is there. 3 over 10. Remember we had talked about this? So it repeats. The correct answer wasn't there the year before, but finally it's there. The correct answer is 3 over 10. Alright. Number 34, which of the following statements is true? Option D. Alright, this is a repeat question from a long time ago. This question here, that the following is true. Looking at right here, what this is saying is 0x plus 0y plus 0z equal 2. That makes no sense. So there is no solution. B. Now it says a high school science class has 15 girls and 20 boys. A competition is held and awards are given to first, second, and third. What's the probability that all 3 awards are boys? So the probability a boy win is 20 out of the 35 times probability a boy come second is 19 out of 34 times 18 out of 33. There's a probability we get all 3 boys. 20 times 19 times 18 divided by 35 times 34 times 33, 0.174. That's it. A team of 3 is chosen from 4 boys and 3 girls. In how many ways can this be done so that the team has 2 girls? I don't like this. What do they mean by has 2 girls? Do they mean has exactly 2 girls or have at least 2 girls? I'm going to take it as it means exactly 2 girls. So I thought they need to clarify that question. Alright, so exactly, because has 2 girls, I guess they mean exactly 2 girls. So now we're choosing a team of 3 from 4 boys and 3 girls. But we need to choose how many girls? 2 girls. Out of them 3 there. And so 1 boy can end up from the 4. So 4 choose 1 times 3 choose 2 is C. Now they said the probability that a newborn baby is born is 0.4. What's the probability that a family with 3 children, there are 2 girls, 1 boy? So the probability of baby being boy. So the probability of being boy is 0.4. Probability of being girl then is 0.6. So what's the probability that a family with 3 children, there are 2 girls and 1 boy? So the probability of getting 2 girls and 1 boy. Now it don't have to be in this order, right? So it could be that you get probability that you get a girl, then a boy, then a girl. Or it could be that you get a girl, then a girl, then a boy. Or it could be that you get a boy, then a girl, then a girl. So look at all the possibility: girl, boy, girl, 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 boy, boy, girl, girl. Yeah, so cover all bases. discover when boy is at each. So now we need to work out that girl is 0.6 times boy is 0.4 times 0.6. Then that result will multiply by 3, which is 0.432. That's D. So if a marble is chosen without replacement, then the probability of getting red marble followed by 2 blue. So we need to get a red then 2 blue. And it says without replacement. So there's 9 red to choose from. So it's 9 red out of 20 times. If we get a red and we get 2 blue, it's 19. But that's 11 blue. And if we take a blue, 10 blue remain out of 80. That's all we're looking for. 9 over 20, 11 over 19, 10 over 18, B. So much probability here. This one is a repeat. The one with the number of 3-letter words, and I remember it was 60. Number 41, probability L occurs given that K occurs. So L occurs given that K occurred is the probability of L intersect K over the probability of K. L intersect K is 0.15 over the probability of K 0.6. We do the division, that's a quarter. This one now, what's the value of X? And the determinant is 62. Set up the determinant equation 2 times cross the row and column with 2 in it. That's x plus 8. Then minus 3 times cross the row and column with minus 3 in it. So that is 5. Then that is plus 6. Then cross the row and the column with 1 in it. So the final one we cross, that is 5 minus 3x equals 62. This is 2x plus 16. 5 plus 6 is 11. 11 times 3 is minus 33. Plus 5 minus 3x is 62. 2x minus 3x is minus x. 16 minus 33 plus 5. I can't bother because I'm tired. 16 minus 33 plus 5. That's what we have. We have minus 12. Make sure we didn't do anything wrong. So 5 times 4 is actually 20. See there? Giving it away, this is supposed to be 20 minus 3x. This would be 20 here. So now let me re-put that in the calculator. It's 16 minus 33 plus 20. That's positive 3. And then I bring that over to the other side. So now something off. So let me redo it over again. So pure mistakes there. Pure mistakes. That's what happened. It's almost midnight. So you know how it goes. So we're going again. Sorry about that. Cross around the column. So it's 2 times x plus 8. Going very slow. Then plus 3 times. Cross around the column with the 3 in it now. 5 times 1 is 5. Minus 6, that's plus 6. Plus 1 times. Cross around the column now with the 1 in it. That is 20 minus 3x is 62. No, that's 2x plus 16 plus 33 plus 20 minus 3x is 62. This is negative x equals 16 plus 33 plus 20 is 69. Bring over 69. So 62 minus 69. So negative x is negative 7. X is positive 7. Done. Now M is a singular matrix when x has a value. So all we have to do now is set this equation, the 2x plus 16 plus 33 plus 20, remember, is 69. So minus 69, positive 69. So plus 69 minus 3x equals 0. So if the determinant is 0, carry it over. 2x minus 3x is minus x plus 69 equals 0. So x is 69. When x is 69, then it's singular. Number 45, big repeat A. We did that in the last year paper. And 44, general solution. The first thing now, put this as m squared minus 3m equals 0. M in bracket, m minus 3 equals 0. So I get m equals 0 or m equals 3. So from that now, a general solution is y equals a e to the 0 x plus b e to the 3x. Anything to the 0 is 1, so that's a plus b e to the 3x. So looking at that's out. C1 e to the 3x plus C2, C is correct. So we finished this paper, but no, remember there's one that we left out, and that's the one about diverges. All right, so which of the following diverges? The first one doesn't diverge, it is alternating between 1 and minus 1. The second one definitely converges, so we know we're looking between C and D. So we're just gonna wrap it up fast. Let me just erase these. Let me look at a number like 5,000 in this one. Fraction button. 4 in bracket 5,000 minus 3 over 2 raised to the 5,000. Math error. So the calculator can't do 5,000. We change it to 100 and see what happens. Times 10 to the minus 28. So this is getting very, very, very small. This is approximately 0. So we change it now from 100 to 150. 150 gets even smaller. Change it to 200. Change it to 200. This gets even smaller. Even smaller. So this one is definitely getting so small, and it's not even becoming negative. You notice it's just getting smaller. This one converge. This one definitely converge, like we said. So the only one that can diverge would have to be the last one, but I want to see if there's something wrong with the question. The last one, no. We're testing log. Let's use 200 first. Log 200 divided by e raised to the 200. That's very small. So we'll go bigger now, and let's go 500. Math error. Can't go 500. Let's go 300. Can't go 300. Let's go 250. We'll have to get an idea of what's happening. Is it converging? Is it getting smaller? Can't go 2. We just went 200, so it can't go. Let's go 210. Get smaller. Let's go 211. That's getting smaller. That's 10 to the minus 1. Let's go 215. Getting smaller. So they all converge. This actually converge. So there's no solution here. These three definitely converge. This one we can't say it diverge. It's alternating. It's alternating. So minus 1 to any power will either give you 1 or minus 1. This is actually alternating. So none diverges, alright? So I don't know what CXC is doing, alright? So none diverges here, alright? So that's it for this paper. None diverges.